page 3. Here's going to be an example of when you cannot do matrix multiplication. So here we want to find the product of A and B. A comes first, then B. And I look at matrix A and I realize, hey, I have 2 rows, 4 columns. So A is a 2 by 4. B, I have 3 rows and 2 columns. So that's a 3 by 2. And because that's a 3 by 2 and that's a 2 by 4, the insides do not match, so I cannot do it. Alright, so in general, matrix multiplication is not commutative. It says in general because usually it does not work, but there could be some special cases where it does work, but that's, if, just the multiplication happens to work out. It's not really anything special about that. Now, that is, given matrices A and B, it is true in most cases that A times B does not equal B times A. So now, multiplicative properties of matrices. So we're going to let A, B, and C be matrices whose sizes are multiplicatively compatible. C as a scalar. So if I'm doing A times B times C, that's going to be equal to A times B times C. Matrix multiplication is associative. I can also use the Schroeder property with matrix multiplication, either the front ways or back ways. And then here we have the associative property with the grouping. Now, that's with the scalars. All right, we can move the scalar around because it's just a scalar. Notice that when we still have this, A comes first for all these, B comes second, so the order does not change. Now, the next thing we're talking about is addition and multiplicative identity of matrices. So, the zero matrix is just a matrix that's made up of all zeros, and that's going to be the additive identity matrix. Whenever I'm adding a zero matrix to a matrix, I'm going to get back that in whatever matrices that was. So if it's A plus the 0 matrix, or the 0 matrix plus A, I'm still just going to have A. Now again, I can only add them if they're the same size. Alright, so if I have a 0 matrix that's a 2 by 3, but I have a matrix that's a 3 by 3, I'm not going to be able to add those because they have to have the same size. Now, the multiplicative identity matrix is usually referred to as the identity matrix with a capital I. It is an n by n matrix, so it has to be a square matrix in order for us to have an identity matrix. And it's defined by basically a matrix that has all zeros except for a diagonal of ones. And that's basically why it has to be a square matrix, because the ones have to go diagonally across your matrix. Your first element of your first row and first column has to be 1. Your last element, so your last row, has to end in a 1, with the last column ending in a 1. Right? Note that the identity matrix has 1s on the main diagonals and 0s elsewhere. So here you can see, identity matrices.